So in this circuit, we are looking for symmetry. So if you understand symmetry method, it is a very simple question which is to be solved. So if the current is entering at this end and leaving on the other end, so we are finding that the current when it enters this end, it find three identical networks like this. Although it must be noted that the current in each network is not going to be same. Similarly, when the current is reaching B, it is coming back to these three networks. So following the rule of symmetry, I can say that these two nodes will be equipotential nodes, and hence this 3 ohm is not going to contribute to any flow of current, and we can remove it out. So if we are removing this resistor, so we can redraw this diagram in this way, that there is a 3 ohm and the another 3 ohm, the 3 ohm in the lowest trunk, and these two resistances between A and B. So if we redraw it this way, this is 3 ohm each. So I say this is 6, 6 and 3. So the effective value or R parallel can be written as 1 by 6, 1 by 6 plus 1 by 3. So R parallel is equal to 6 by 4. That is equal to 3 by 2 or 6 by 4 ohm. It is matching with option 4. So this is the correct alternative.